so for problem number 2, we have this formula that is temperature is equal to 2 pi times square root of length divided by gravity. So gravity, we know that is 9.81, negative 9.81, but we're going to use it positive because it's in a square root. So for problem number A, we are asked to find the change in period of pendulum. That means to find the increment. And with a given length of 4 feet, so therefore we know that the length number 1 is 4 feet. And for length number 2, we know that it's increased in temperature and length increased by 1/2%. So 1/2% is the same as 0.5%. So to get 0.5% of 4, we just put 4 plus 4 times 0.005, and we get 4.02, which is going to be our length number 2. So to get the change in period of pendulum, or the change, we do T2 minus T1. That means that in the original formula, we're gonna substitute first length number 2 and then length number 1 in here and in here. We subtract. You put it in your calculator using the correct parentheses in order to get the correct answer, and the answer you will get is 0.01002.
In part B, it asks us for the percentage of change. For the percentage of change, we need to know the change in T and Tx1. Change of T and Tx1, we got it from point A, and we will just substitute them into the formula. So it will be 0.01002 over 4.012 times 100, and we get the percentage, which is 0.2497%. In part C, it asks us for the approximate. In the approximate, we have two derivatives. So therefore, we have 2 pi times square root of L, because we will separate the square root of L over gravity, times 1 over square root of 9.81. We multiply 2 pi times 1 over 9.81, and we have 2 pi over 9.81 times L to the 1/2, because we can have radicals. We now derive dt over dl, and that will equal 1/2, so multiply this, times 2 pi over 9.81 times L to the n, which is 1/2 minus 1. We would also move the dl multiplied at the end. Therefore, we have now dt will be equal to pi over square root of 9.81 times L to the negative 1/2 times dl. We have now dt will be equal to pi over square root of 9.81 times square root of 4, because we know that L equals 4, times dl, which equals 4.02 minus 4. We multiply this and we get that dt equals 0.0100.
So for letter D, we can approximate the error in 1 day. So we have to get the seconds, the total seconds in 1 day. So we're going to multiply 60 times 60 minutes times 24 hours. So we're going to get 86,400 times 0.0100, which we got to approximate in the letter C. So we got in total 864.00. And this represents the seconds of error in 1 day of a pendulum.
Hi, we're going to do problem number 5. It's a simple integration problem. First, we have to observe that there's a square on the equation. So we have to expand. We square the first one, then multiply the first one with the second one, times 2, and then square the second one. And this is the result. After that, we have to move the x squared to the top because we cannot have a variable on the bottom. Here, the negative 6x stays the same, and this as well. Then we change the dx to integration of fx dx, and we add a plus e at the end. We have the x to the negative squared. To integrate, we have to add 1 to the exponents. So negative 2 plus 1 is negative 1, and we put it under negative 1 as well. And here with the negative 6 as well, the 1 plus 2, 2, and we put the 2 on the bottom as well, and we do the same rule here. Then we just simply simplify with the 6, negative 6 over 2, and the 4 plus 5 times 5, and we pass the negative x to the negative 1 to the bottom. This is the final answer.
We're gonna do problem number 9, which is integration of 14 square root of x. We open up an parenthesis, is x squared minus 5 over 2 square root of x plus pi, close parenthesis, dx. We know that we have to multiply this term by each one inside the parenthesis, and we're gonna have 14x squared square root of x minus 35 plus 14 square root of x pi. We know that the square root of x is 1 half, so we add x squared plus x 1 half, which is gonna be 5 over 2. We leave the negative 35 the same. It's gonna be 4 plus 14 pi of the same of square root of x is 1 half, x 1 half, and we're gonna start integrating, which is, we know the rule that if you got a variable to an exponent of a fraction, you add the first term, the numerator times you add the numerator to the denominator, and you're gonna have 7 over 2, and you do the reciprocal, and you multiply it times your number. The negative 35, you just add an x, and you do the same step in the second one, such as you did in the first one. Then the 7 cancels with the 14, which is going to be 2 times 2, it's going to be 4x to the 7 over 2, minus 35x, you leave the same, plus 14 times 2, 28 over 3, pi of x to the third over 2, plus c. And the final answer is going to be integration of fx dx equals 4 square root of x to the 7th minus 35x plus 28 pi square root of x cubed over 3 plus c.